Question number 6. So when you are doing a work done, so when you are lifting an object, the work done is a product of force into distance. So force which you will apply, the minimum force should be 10. Practically it will be more than 10, but minimum is 10. Multiply by distance which we move, it's 1 meter. So 10 multiplied by 1, so for A we'll get 10 joules. But if we calculate a work done for B, the force which you apply multiplied by distance you move. So how much force pushing through a 1 meter against the frictional force of 4 Newton. So if frictional force is 4 Newton, minimum force to move this object, we have to apply 4 Newton to move. So the force which we apply is equals to force and the 4, and the distance which we move is 1. So 4 multiplied by 1, that's equal to 4 joules. You are lifting a 2 meter object of 2 kilogram to a height of 2 meter. So work done again, it's force multiplied by distance. When you are lifting an object, the force is equals to the weight of object, which is 20, and the distance which you move, that's equal to 2. So 20 multiplied by 2, that's equal to 40 joules. And pulling through 2 meter against the frictional force. So if you're doing a force which you apply is 2 Newton, because if frictional force is 2 Newton, and if you want to move this object, your force should be more than 2. Minimum will be 2, but it should be practically more than 2. So you apply a force of 2 Newton and you move the object to a distance of 2 meter. So 2 multiplied by 2, that's equal to 4 joules. So which is having the highest work done? C is having the highest work done. So when you are lifting the object, the minimum force which you apply is equals to weight of the object. When you are dragging the object or pushing or pulling the object on the surface, the minimum force which you should apply should be equal to the frictional force. It should be more, practically it will be more than frictional, but minimum it should be equal to frictional force. Is this clear? Question 6.
Yes, sir, clear.
So dragging the object, when you drag, push or pull the object, the minimum force should be equal to the frictional force. Lifting an object, minimum force equal to the weight of the object. Question 7, what could be the answer for question 7? As energy transfer into different form, it eventually become dissipated. Dissipated means changes to other form or lost.
See.
So all the energy disappear. Energy cannot disappear. Energy cannot be created nor be destroyed. It only changes from one form to another. Energy finally changes to every possible form. No, it's not wrong. It's not correct. It's not every possible form. Like example, if you have a car engine, the car engine is converting kinetic energy to kinetic, heat, sound, but not all other forms. Energy spread out among the object and their surrounding. Basically, what happened? Energy dissipated, some of the energy lost to the surrounding, and some of the energy still with the object. So C is a, and the total amount of energy become less. The total amount of energy remain same, does not change at all. Now in question 8, a ball of mass 1.2 kilogram is dropped from a height of 30 meter. As it falls, 25% of its initial gravitational energy is transferred into thermal energy, or basically 25% is lost. The heat energy is a lost energy. What is the kinetic energy? So you can solve this question by a formula for efficiency. First, you will use the formula of efficiency. So the formula for efficiency, so efficiency is equals to useful energy divided by input multiplied by 100. That's a formula for efficiency. A ball is dropped. So at the height, this ball will have potential energy. And before hitting, it will have kinetic, maximum kinetic. And some of the energy is lost. How much energy is lost? 25% is the lost in the form of heat. So what is the efficiency? Efficiency is not the lost energy. Efficiency is the useful energy. So if lost is 25, how much is the efficiency? Efficiency, maximum efficiency is 100. Out of 100, 25% is lost. So how much is the useful or efficiency? So efficiency is 75. What is the useful energy? The kinetic energy. What is the input energy? The potential energy multiplied by 100. Is this clear? Why I took 75 here, not 25? Because 25% is lost. And the formula for efficiency is the useful energy divided by, so efficiency, useful energy divided by input multiplied by 100. So we need a kinetic, but what is the potential energy? So we have the mass, which is 1.2. We have the height, and we know the gravity. So potential energy is how much? Potential energy is mgh. The mass is 1.2, gravity is 10, and the height is 30. So 1.2 multiplied by 1.2 multiplied by 10, it will be 12, and 12 multiplied by 30, this will be equal to 360. So 360 joule is a potential energy. We need kinetic. So this is 75. Kinetic divided by potential. So how much is potential? It's 360 multiplied by 100. So 360 is divided, other side it will be multiplied, and 100 is multiplied, other side it will divide. So it will be 75 multiplied by 360 divided by 100. What is the answer?
270.
270. So C is the right answer. To 270 joule is there, the kinetic energy. Is this clear, this question?
Yes, sir.
Look, in this question, the mass of object is 1.2. The height from which it is dropped is 30 meter. This is a wasted energy. 25% is a waste. So what is the efficiency? Efficiency is a useful one. So how much is a useful? 75% is useful. Now, when you use the process, the energy change here. So in this question, efficiency, which is denoted by N, is equals to useful output divided by total input multiplied by 100. Efficiency of the process is 75. That's why I put 75. What is the output energy? Because this object is falling. So in the falling object, because object will at certain height, will be at certain height, so it will have potential energy. When it comes down, the final energy will be kinetic energy before hitting. So useful is a kinetic, input is a potential multiplied by 100. What is the potential energy? Is mgh, mass into gravity into height. So I can write in here as well. That kinetic energy we don't know, and potential energy is mgh into 100. M is the mass 1.2, h is the height, and g is the gravity, which is 10. So this was 75. So this was 75. Mass of object 1.2, gravity is 10, and the height from which it is dropped is 30, and multiplied by 100. This whole factor is multiplied, it will to each other and divided with kinetic energy, other side it will multiply. This 100 is multiplied, other side it will divide. So when you solve, you will get final answer as 270. Next question. A girl hangs by her hand from a bar in a gymnasium. She pulls herself up until her chin level with the bar. The mass of the girl is 48 kilogram. She pulls herself through a distance of 0.25 meters, and she does this in 2 seconds. What is the useful power? So how to calculate a power? Whenever you have the formula for power, power is work divided by time. And what is work or work done? Work done is force multiplied by time. Whenever you are lifting yourself, whenever a person or object is lifting, what is the force? The force is equals to weight of the object. So if mass is 48, what is the weight of the object?
480.
480. So we'll multiply by 10. So that's 480. Multiplied by distance, it moved to a distance of 0.25 meters. So as we move to a distance of 0.25 meter, so this will be 0.25. This will give you a work done. But you don't need work done, you need power. So power is work done divided by time. So you can directly use the formula. So power is equals to force into distance divided by time as well. Work done divided by time, or force into distance divided by time. So force is 480, distance is 0.25, and it took how much time it took? It took 2 seconds. So that's why divided by 2. So when you solve, it will be 60 watt or 60 joules per second. Is this clear? Discussion?
Yes, sir.
Two cars, P and Q, have different masses and different speeds. Which row compare the momentum and which row compare the kinetic energy? Momentum is a product of mass and velocity. W can be used for weight. W can be used for work done as well. In the previous example, this W and D, why I use WD, it means work done, which is force multiplied by distance. Or you can say work, simply work. So the formula for momentum is a product of mass and velocity. And kinetic energy, this is a formula for momentum, and kinetic energy is half mv square or 0.5 mv square. What is the right answer? When you compare the momentum and you compare the speeds, which is having the higher momentum and which one is having the higher speed, or maybe speed momentums are equal. Yeah, what's the answer? So C is the right answer. Both have the same momentum because when you multiply mass with velocity, you get the same answer. But when you find the kinetic energy, which is half mv square, you'll find kinetic energy of car Q is higher as compared to that of C. In question 11, a car of mass 800 kilogram, so mass of the car is 800 kg. It travel over a hill of height h. By traveling at the top, the car gains a potential energy of 40,000 joule. So the potential energy of the car at this point is 40,000 joules. What is the height? So how to find the height? You will use the formula for potential energy. So potential energy is mass multiplied by gravity multiplied by height. Potential energy is 40,000. Mass of the car is 800. Gravity is 10. And height you don't know. If this is multiplied, this factor, other side it will divide. So it is 40,000 divided by 800 into 10. What's the right answer? So A is the right answer, which is 5 meters. Question 12, the last question for today's class. Next class we'll discuss more questions related to this energy. A lamp has a power input of 5 watt. 1 watt is wasted. What is efficiency? The formula for efficiency is equals to useful output divided by total input multiplied by 100. So efficiency, useful output is 4. Why? Because out of 5, 1 is wasted. So 4 is a useful. Divide by 5 into 100. When you solve, you will get 80% efficient. Is this clear?
Yes.
Okay, we'll do more questions related to this energy topic next class, and prepare for test of multiple choice questions related to block 1 on Sunday.